Hello, Year 5. Good morning. It's Mr. O'Brien. And I just wanted to say it was great to see some of you back at school last week. Also, another thing, while some of you are back at school, it's also really important that you continue to upload your home learning onto your Class Dojo accounts so that we, myself and Mr. Turnham, can have a look at that. Okay? So remember to do that, please. On the screen at the moment, you can see worksheet 5 on comparing decimals. This was the second worksheet that you completed for last week's work. I would just like you to pause the video now and go over this, please. Okay, so let's get going with today's lesson. This is another one on comparing decimals. So we're going to be continuing with this. And our non-negotiable today is pupils can arrange decimal numbers in order of size using place value blocks to help if necessary. Okay, so we've looked at using place value blocks with this, but on the screen because we don't have any to hand. Okay, so let's have a look at the learning for today. Our in-focus task. I've got 3 bags here. An orange bag, which has 2.5 kilograms in it. Pink bag with 2.125 kilograms in it, and a blue bag with 2.15 kilograms in it. Maybe they're sweets or potatoes or anything. Okay, so we've got a statement here from Orange Top about these bags. What's she saying? She says 2.125 kilograms must be the heaviest because 2.125 kilograms has the most digits. So she's saying that the amount of digits in a decimal number show that it is greater. So the more digits the decimal number has, the greater the number. Do you think Orange Top is right? Or do you think Orange Top is wrong? Let's have a look. We've got Green Top here. She is going to help us, okay? She's represented all these different weights using place value blocks. We've got A, B, and C. What I would like you to do is write down the value of B and C in written form. So I don't want it in decimals, I don't want it in fractions, I want it in written form. I'm going to show you what this would look like. You should be familiar with this already. For A. With A, I can see I have two holes and 5 tenths. And that's what I've written here. 2 holes and 5 tenths. So I would like you to write down the values of all the different place value blocks for B and C. You pause the video and do that, please. Okay, so let's have a look over these. For B, we've got 2 holes, 1 tenth, 2 hundredths, and 5 thousandths. And for C, we've got 2 holes, 1 tenth, and 5 hundredths. So we can use this information to find out if Orange Top's statement here is correct. Well, I can see here I've got 2 holes and 5 tenths. I immediately can see that 5 tenths is more than 1 tenth. So Orange Top's statement cannot be true. It isn't the amount of digits we have in a decimal number that make it greater. It is the value of those digits. And we know that tenths are greater than hundredths, and hundredths are greater than thousandths. I can see here I've got 5 tenths. In 2.125, I've only got 1 tenth. So 2.125 cannot be the greatest just because it has the most digits. So we've got these written down. And I'd like you now to put them into order using the lesser than symbol. So we're going to be going in ascending order from the greatest to the smallest. I would like you to write the decimals in ascending order. Okay, so our first decimal, our smallest one, will be 2.125, and that is less than 2.15. We've got 2.15, and I know that that is also less than 2.5. Okay, so actually, Orange Top's statement was completely wrong. 2.125 is the smallest value. 2.5 is the greatest value. So 2.5 kg, heavier than 2.125 kg. Okay, so we're going to look at this in some different ways now. Some of the ways we looked at last week. So we're looking at, firstly, Orange Top's method. Now he's got here 2.125 equals, 2.15 equals, 2.5 equals. We are going to be converting Orange Top's decimals here into thousandths. Now, I think this one is quite easy. We've got our two wholes, and we've got 0.125. I know that it's 125 parts of a thousandth. So I already know that this is 2 and 125 thousandths. So I can put 2.125 equals 2 and 125 thousandths. So I've done this one with the thousandths. I would like you to convert this B and this decimal C to parts of a thousandth. Okay, so using your knowledge of thousandths. If you pause the video and go through that, please. Okay, so we've got 2.15, and that equals, well, first of all, to make it a bit easier for myself, I'm going to look at it as part of a hundredth. 2 and 15 hundredths. Well, I know that that is also the same as 2, whoops, and 150 thousandths. So I've gone from 2 and 15 hundredths, and I know that in 15 hundredths I can find 150 thousandths. Okay, let's just write that as a fraction here. As a fraction here. So 2 and 15 hundredths equals 2 and 150 thousandths. Okay, let's look at C. 2.5. Well, that equals 2 and 5 tenths. I'm not going to even go to, sorry, I'm not even going to go to my hundredths. I'm going to go straight to my thousandths, because I know that 2 and 5 tenths also equals 2 and 500 thousandths. Okay? I know that in 5 tenths, I can also make 500 thousandths. So, using this, again, I can see that 2.125 is smaller than 2.15, and that 2.15 is smaller than 2.5. And I've used my knowledge of thousandths to help me find that. Okay. Now let's look at Yellow Top's method. So Yellow Top is using my really handy method from last week. Yellow top is focusing on the first decimal place. But I think she might have a problem here. What's the problem with Yellow top's method in this case? Okay, well, I can see here that Yellow top has written down her decimals and she's ignored any other digits apart from the first decimal place. So we've got 2.1 and 2.1 and 2.5. Now, I already know that 2.5 is greater than 2.1. So I know that my largest decimal is going to be 2.5. But I'm still not sure about these two. What could I do to find out which of these two decimals is greater? Well, in this case, I have to look at the second decimal place. So I can ignore the last decimal place, but I have to look at the second decimal place. So I've got 2.12 and 2.15. Well, as I say, I haven't been able to use the first decimal place to find which of these is greater, but I can look at the second decimal place, and I can see that this place here in the hundredths column, the 2, is smaller than this digit here in the hundredths column, the 5. So I know I can write these, again, using my lesser than symbol and writing them in ascending order from the smallest to biggest. I can write them as 2.12 is smaller than 2.15. And I, of course, know that both of those are smaller than 2.5. So here, because I haven't been able to use my first decimal place, I've looked at the second decimal place, and that has helped me work out which of these decimal numbers is greater than the other. Okay, so we're going to move on to our guided practice for today. And we're going to be arranging the numbers from the smallest to the greatest. We're doing this again with these numbers. So I'd like you to pause the video here, and I would like you to use 2 different strategies to arrange the numbers from the smallest to the greatest. For A, I would like you to do this by turning these decimal numbers into thousandths. And for B, I would like you to arrange these into order by looking at the amount of decimal places. Okay? So if you pause the video, and then we will take a look at this together. Okay. So I'm going to move this down here, and we're going to look first of all at A. So my first number is 1.325. My next number is 1.352. My next one is 1.532. Well, actually, I can see that all of these numbers are already to 3 decimal places, so I can automatically change these to thousandths. The first one would be 1 and 325 thousandths. Remember, you don't have to write "and" in the middle here, but because it can be quite hard to write fractions clearly on the computer, I'm just doing this to separate these 2 numbers. My next one is 1 and 352 thousandths. My next one is 1 and 532 thousandths. Okay, so I've done that, so I can now look at these figures and arrange my decimals from the smallest to the greatest. Well, already I can see that this one is going to be the greatest because it starts with a 5. These two are smaller. Now I have to compare these two to find out which is smallest. In the first column, in the tenths column, they're the same. So I have to go to my second column and look here. Well, this one is 2, and this one is 5. So I know that 1.325 is smaller than 1.352. And then I know that my largest number is 1.532. Okay? So that's A. I now want to look at B. I'm going to look at that here. So I am going to use that second method of just using the first decimal place, and I'm going to see if this works for me. So my first one is 0.9. Oh, my second one is also 0.9. My third one is 0.9. So actually that hasn't helped me at all. So what do I have to do? Well, as we know, I have to go to the second decimal place to help me work out which one is greater. Well, in my first one, I don't even have a second decimal place. I could put 0 in there, but there's nothing there, so I don't have to. For this one, I've got 5. And for the last one, I've got 1. So I know that this one is going to be my smallest digit, my smallest number, because it's only got 1 digit in the 10th column and it hasn't got anything after that. These two do, so they are greater than this number. So I put here 0.9, smaller than, and then I've got to compare these two numbers. Well, I can see here in the hundredths column, I've got 5, that's my digit, so it's going to be greater than 1. So I have to put here 0.91, and that is less than 0.95. Okay, so we've just gone over some of those methods that we looked at last week again. For the worksheet, you're going to be doing a bit more of that, and there is also a challenge in which you'll be arranging decimals into a bit of a puzzle. So those are your tasks for today, and I'll speak to you again for the next lesson tomorrow.